In today's video, I will talk about trig ratio of any angle in Math 11. So in Math 10, we already have learned trig ratio in a right angle. And when it comes to grade 11, we have to learn the trig ratios in basically any angle. So let's first take a look at the prerequisites in this chapter. So in an xy coordinate, you can generate an angle by rotating a ray about the origin. So here comes some new terms. The starting position of the ray along the positive axis is called the initial arm of the angle. And the final position after rotation about the origin is called the terminal arm of the angle. An angle is said to be an angle in a standard position if its vertex is at the origin and its initial arm is the x-axis. So we have quadrant 1, 2, 3, 4. In quadrant 1, the angle is from 0 to 90 degree. In quadrant 2, an angle gonna be 90 to 180 degree. In quadrant 3, an angle gonna be 180 to 270 degree. In quadrant 4 is 270 to 360 degree. And a new term, reference angle. Reference angle means the acute angle whose vertex is the origin and whose arms are the terminal arm of the angle and the axis. So for example, the angle 230, the reference angle is 230 minus 180, that is 50 degree. So some example, in general, angle in quadrant 1, the reference angle is itself. In quadrant 2, the reference angle is 180 minus theta. In quadrant 3, it's theta minus 180. And in quadrant 4, it's 360 minus theta. So that's pretty straightforward. And we look back at two special triangles that we already learned in grade 10. That is 45, 45, 90 right angle. So we know that this triangle is 1, 1, root 2. And sine 45 degree is 1 over root 2. Cosine is 1 over root 2. And tangent is 1. And another special angle is 30, 60, 90 triangle. So it's 1. Yeah, usually I would recommend students to memorize this graph. It's 1, 2, root 3. So we can calculate the trig value by ourselves. So basically when the question comes, I will draw a 1, 2, root 3 triangle on paper and try to calculate any value here by my own. So you don't have to memorize. You just need to remember this graph. Okay, these are the prerequisites. So let's come to finding the trig ratio of any angle in a standard position. So here comes to the definition. Suppose theta is any angle in standard position, and a point xy is any point on its terminal arm. So the distance r here is equal to x squared plus y squared square root. So it's that you can use the reference angle to determine the three primary trig ratio in terms of x, y, and r. And by definition here, sine theta is equal to y over r, cosine theta is to x over r, and tangent is y over x. But remember, this is actually applies to any angle. So for example, here, we pick a point, any point of x, y on the terminal arm, and we can calculate the trig ratio the same way. But the trig ratio can be negative because, for example, here x is negative, right? Another very useful technique that you can use is the unit circle. A unit circle is a circle with radius of 1. So when r is equal to 1, it becomes very easy. So it's the greatest way to learn trig ratio. So when r equal to 1, sine theta equal to just y, right? Cosine theta equal to x, and we have x squared plus y squared equal to 1. So this graph gives some values of some very often shown angles. For example, 30, 45, 60, and those angles. And to calculate the trig ratio of those angles, you can basically pick a point on the unit circle and find its coordinate. So for example, what is cosine 360 degree? So 360 is here, and this is a 30 degree triangle, and we can, because this is 1, so this is 1/2, and this is square root of 2. That's why the coordinate here is root 2 over 2 and the negative 1 over 2. So cosine 330 degree is equal to root 3 over 2, and the sine 330 degree is equal to negative 1 over 2. Another thing that you have to be very familiar with here is the signs of the trig ratio in different quadrant. So in quadrant 1, we can see because x, y is both positive, so sine and cosine is both positive. And in quadrant 2, sine is positive, cosine is negative. In quadrant 3, both are negative. And in quadrant 4, sine is negative, cosine is positive. It's actually pretty straightforward when you consider either in unit circle or just pick a random point with the coordinate in different quadrant. So let's take a look at examples. Example 1. Suppose theta is the angle in standard position with terminal angle in quadrant 3, and the cosine theta equal to negative 3 over 4. What's the exact value of sine theta and tangent theta? So you should be able to do these kind of examples, and that's it, right? So here in quadrant 3, we know the terminal arm in quadrant 3, and cosine theta is negative 3 over 4. So this is r is 4, and x is negative 3. And we can calculate y equal to 4 squared minus 3 squared by the so 16 minus 9 equal to root 7. This is Pythagorean theorem, right? So root 7. So we have sine theta is here, y is negative, so sine theta is negative 7 over 4. And the tangent theta is just a negative 7 over negative 3, which is positive, right? Just correspondent with the signs of trig we previously learned. And this example, let's look at this one. So sine theta equal to half, and theta is in from 0 to 360. So we have to find the theta. So solve this one. We know because sine theta is positive, so theta can either be quadrant 1 or in quadrant 2. And we can calculate, because sine theta is 0.5, so theta is equal to 30 degrees. For this one, we can just memorize the special triangle, or we can just use sine inverse in our calculator to find theta equal to 30 degrees. And because the reference angle is 30 degrees, so the angle is 150 degrees or 30 degrees, right? So two solutions. And the last one, solve for an angle given is sine, cosine, or tangent value. So this example, cosine is equal to negative something, and we have to calculate the degree, calculate this degree. So here first let's determine the quadrant. Because cosine is negative, it should be either in quadrant 2 or quadrant 3, right? And then it says use a calculator to determine the angle that cosine theta equal to this. This is very important. Here we should use the positive value of any value here because we are calculating the reference angle, and then we have to input in the calculator with the positive value. So here, by using calculator, we find out the reference angle is equal to 47.5. So again, it's two solutions, and one is 180 minus theta, that is one solution, and the other in quadrant 3 is 180 plus the theta, another solution. Okay, thanks for watching. Hope you enjoyed.